Welcome back to our refrigeration training. So what we're going to do in this video is we're going to talk a little bit about using the low pressure switch as a temperature control. Some of the older refrigeration systems do not have a thermostat on them. They use the low pressure for temperature. So going into this, before I get into the actual material, I do want to just ask you folks to please subscribe to my channel. You get notifications when new video comes out. Your subscriptions let me know I'm doing something right. Helps get the word out about my channel. And they're very important for YouTube creators. Okay, it helps support the channel. It's really easy. Go to my channel, click the subscribe button. 2 steps. Okay, so let's talk first before we get into the actual how it works using the trainer. Let's talk about one thing or 2 things that we have to get to first. First of all, every evaporator out there, that's the evaporator, the cold part of the system, has a design temperature difference. Okay, I talked about this in one of my other videos, but for refrigeration, okay, if it's a reach-in or a case refrigeration, your evaporator temperature is going to be about 10 degrees below box temperature when it's running. In a walk-in, that's going to be about 20 degrees below box temperature. Actually, on a walk-in, I got them confused. 10 degrees on a walk-in, 20 below on a reach-in. Okay, which means that if my box temperature, if I want a 30-degree box temperature for a walk-in, my evaporator should be 20 degrees. If I want a 30-degree box temperature for a reach-in, my evaporator is going to be 10 degrees. Okay, now it's different for air conditioning, okay, which will depend based on airflow and evaporator size. But those are just some general rule of thumbs. Okay, so we always want my evaporator between 10 and 20 degrees below box temperature. That's a good thing. Okay, so we base our pressure controls on this. The other thing we have to talk about is 3 terms: cut in, cut out, and differential. The cut in is the pressure at which the pressure switch will close and energize the compressor. The cut out is the pressure at which the pressure switch will open and de-energize the compressor. The differential is the difference between the two. So this is an example of a pressure control. This is the one that's right now on the trainer that I'm going to show you some video and we're going to actually set up to operate properly using this. Okay, you'll see that we have a high pressure side. We're not going to worry about that right now. We're going to worry about the low pressure side, which is the left-hand side of this. When we open up the pressure control, okay, you see that there are 2 wiring connections. This is a combo pressure switch, so I don't have separate wiring for my low pressure and high pressure side. That's fine. It's going to achieve the same thing, and it actually gives more protection. So my low pressure side is what I'm worried about. Now, it's very important to take a look for any notations because every pressure control is a little bit different. This one says cut out is cut in, less differential. It closes on a rise in pressure. Okay, so my cut in, I'm going to erase that. I'm going to erase that pen right now. But my cut in is over on the right-hand side. This is my right-hand adjustment. My differential is here on the left. So again, cut out is cut in, less differential. Okay, so my cut in is set for 25 psi. That's where this red thing is. It's about 25 psi. My differential is set for 10. Okay, so cut out is cut in minus differential. So my cut in is set for 25 psi. My cut out is less the differential. So 25 minus 10 means that my cut out will cut the system out, turn the compressor off, or open the pressure switch, depending on how you want to look at it, at 15 psi. Again, cut out is cut in minus differential. Okay, so now let's go ahead and take a look at the actual controls on our trainer. Now, before we get into the actual operation and a demonstration of how this works, let's quickly talk about the wiring. Okay, so we have a service switch, of course, because we start off everything with a service switch. I have my pressure switch. I have a compressor, which is labeled CMP. I have a condenser fan motor, and I have 2 evaporator fan motors on this system. Now, some of these older boxes will not have evaporator fan motors. Okay, it might be just a plate evaporator, or it might be in the actual box casing itself. Okay, so you might not have a fan motor. But in this case, I do have 2 evaporator fan motors that are wired in parallel with each other. So when we're talking about wiring in parallel, okay, we're basically talking about we have this situation going. Well, let me get the green line where I want it. Okay, so what we're doing is we're wiring it in parallel. Okay, remember, in parallel, everything gets full voltage. So coming out of my service switch, I'm going to my pressure switch. Okay, and I'm putting this in green lines only because I want it to be visible. Coming out of the pressure switch, I'm going to my compressor. Okay, and I'm also going to my condenser fan motor because I want my condenser fan motor to run along with my compressor. They're in parallel with each other. Okay, so we're going to come out that way. Now, it is very important that correct airflow is maintained across the evaporator. So what we do, the evaporator fan runs constantly. Okay, evaporator fan in a commercial pressure controlled system does not stop because you have to have airflow and you have to circulate the air in the box. If there's no evaporator fan, okay, it's going to be, you're going to probably have some warmer or cooler spots in the box, again, depending on what type of refrigeration system it is. But in our case, I do have evaporator fan. Now, those all tie in to neutral, okay, or to L2 in our case. Okay, so let me grab the right one. We're just going to bring this up here, and we're going to tie this all together. Now, just because I do like labeling, this would be L1. In this case, this is neutral. So this is the configuration and the wiring of the trainer that I'm showing you. Again, when we talk about evaporator, when we talk about systems that don't have the evaporator fan, okay, this right here, that anything under that line might not be there, okay, if it's a system with no evaporator fan. Okay, but this is our wiring. We are back on our trainer today, and I'm going to mix some of this video in with some PowerPoint slides as well. But what I want to show today is the pressure controls. Now, last video we went over just the trainer and the basic components of the trainer. This is a reach-in, this is set up as a reach-in low-temp refrigerator or freezer right now. So what I want to talk about is the pressure switch. There's a lot of systems out there that use the low pressure switch as temperature control in place of a thermostat. Thermostats were more recent additions to refrigeration systems. So this is a combo pressure switch. Okay, you pull the cover off, you see that there's only 2 wiring connectors inside there. Okay, the left-hand side of this is my low pressure side. Right-hand side it is on a high pressure side. We're not going to talk about the high pressure side right now. I want to talk about the low pressure side. Now, we all know from prior videos and from prior discussion that everything out there has a temperature-pressure relationship. In other words, as the temperature of my refrigerant drops, or the space the refrigerant is in, the pressure is going to drop. So by setting the low pressure switch appropriately, I can have a temperature-pressure relationship, and I can control the box temp based on the pressures. okay, my evaporator pressure very specifically. So I have my low pressure gauge on this system. Okay, I do also have a high pressure gauge. Okay, I use the Testo Gauge Pro, but it really doesn't matter what you use. And my low pressure side right now is running at about a 19.2 psi. That translates for 134A, which is the refrigerant in the system, to 21.2. That means my evaporator temperature is 21.2. Now, what do I care about that for? Well, the reason I care about evaporator temperatures and everything else is because evaporator temperature can be directly related to box temperature or the space temperature. For refrigeration, if you have a reach-in box, okay, and we'll count this as a reach-in, okay, pardon the cardboard on that door, but I have a lot of insulation in there and got to hold it closed. Okay, but if we take this as a reach-in, okay, my box temperature would be about 10 degrees above evaporator temperature when it's running properly. If we take this in as a walk-in, my box temperature, the space temperature, the walk-in should be about 20 degrees above my evaporator temperature. So to set this pressure control properly, once it reaches space temperature, and right now I'm at a 46.5 degree box temperature. I have a thermometer stuck through the wall to get my box temperature. Okay, so I'm a little bit off on evaporator temps, but that's just because I just started this. I'm actually at a 25 degree difference. And again, the space temperature is dropping. So if I want to set this up to maintain let's say a 30 degree box temperature, which would be like for dairy storage and stuff like that, I would want my cut out to happen with an evaporator temperature of about 20 degrees. So what we would do, we have to look at your controls, okay, because in this case, it says cut out is cut in minus the differential. Okay, so the right-hand lever there is my cut in. My left hand is the differential. So in this case, it's set for 25 psi on the cut in, and it's set at 5 or 10 on differential. So it's not going to cut out before the evaporator temperature reaches 15 psi. Okay, so you have to adjust that. Again, the cut in minus the differential is my cut out. We'll come back to this video as soon as the box temperature, I'm going to let it run a bit, and we'll come in and adjust this in the next segment of this. So what's the best way to find out what evaporator pressure we need for a specific temperature? Again, remember, depending on your box, you're looking for 10 to 20 degrees below your expected box temperature or whatever you want your box to be at. So in this case, we are using R134A, okay, which is a medium temperature refrigerant, and this is a temperature pressure chart in which has a column for 134A. So we want to find out what our, let's say we want a 30 degree box. Okay, that's pretty good for dairy products. You could go to 32 degrees, but we want as close to 30 degrees as we can possibly get. That's also good for a beer cooler. So if I want my box temperature for a reach-in to be 20 degrees or for a walk-in to be 10 degrees, I'm going to go, okay, 15 degrees below what my expected box temperature is. That takes me to about a 15 degree evaporator, okay? 30 minus 15 is 15. If I wanted to go 10 degree, I'd do 30 minus 10 for 20. Okay, but because I'm using a training environment, I'm going to go right there. So what you do is you find your temperature, and then you go over to the appropriate column, this is what my evaporator pressure will be. And I'm going to just undo that so that I don't cut the 1 out. So my evaporator pressure at 15 degrees with R134A will be 15 psi. Just one of those that happens to work out. If I went to a 20 degree coil, which would be a 10 degree split, it would be 18.4. But again, I'm going just for the happy medium there. Now, to dial this in, you actually need to get the box to the appropriate temperature and work with it that way. But it's nice to know that the refrigerant you're using and your system setup can actually do this. So, again, to find out what your design pressures and temperatures should be, okay, use a temperature pressure chart. If you happen to be using a low temperature refrigerant or low pressure, let's find, look at 409. 409 is not exactly where I want it to be, but let's look at another one of these refrigerants here. 404 is a replacement for R22. You can actually look at these different temperatures and pressures and find the different combinations that you can use. I mean, I could use 22 and come down to 0 degrees at 24 psi. It's a slightly different refrigerant mix. But in our case, we're going to use 134A. That's what I have in the system. And I'm looking for 15 psi low side. Now, that's going to be my cut out, okay, is I'm going to take it right around 15. My cut in, I'm going to take probably around, 22, okay? So that's what our range is going to be. And because it's easier to read on the scale, I'll probably use 15 as my cut out, and my cut in will be 20. Okay, we're going to continue our conversation. I now have a box that is down roughly around 30 degrees. Okay, my 150 probe is my box temperature. So I have a box that's around 30 degrees. My pressure switch is now set to a 30 psi with a 10 differential. Okay, so my cut out is cut in minus differential. So my pressure switch is cutting out at 20, cutting back in at 30. So, or 19. So I'm right around there, and it just cut out, and it's going to cut back in. Now you see how that's short cycling? We don't want that to short cycle as much as it is, okay? Because short cycling is bad for my compressor. So I'm going to increase that differential a little bit. Okay. And I'm going to pull that differential a little bit closer to the 15. Okay, and we're going to see if that makes a difference on the short cycling. So again, we look at my pressures. My low pressure is dropping. We're down to 19. Box temperature is at 30.7. I really don't want that to drop too much further than that. So I'm going to change, again, this is part of the dialing in, because you don't want it to short cycle. Okay, so I changed that a little bit. I changed my cut in a little bit. So now I'm cutting in at 30 psi, and I'm going to cut out, let's see where it cuts out. Part of refrigeration is hurry up and wait. So we're going to cut out at, should be right around 19 or something like that. Right around 18. Okay, now again, because this box doesn't have any product in it, doesn't have any load. Okay, you see how it's going to try to, based on pressure control, it's going to cut in and cut out. Okay, now again, because of this cutting in and cutting out, okay, face it, this trainer is not designed to hold the cool. Okay, if I wanted to pull that temperature up to like 40 degrees, I could do that as well. I could cut that in 40 degrees. Okay, I could pull this temperature up. I could pull that cut in. Let's cut in at 40. So again, we have our cut in and cut out. And to avoid short cycling, I can change my differential . So I pull my differential up to 20. Now watch what happens. Probably cut out around . But again, you have to if you want to maintain a box temp, you got to dial this in properly. So hopefully that helps a little bit on how a low pressure control can be used to control temperature. And again, because we're in a trainer environment, I gain a lot of heat through the case. If this was an actual refrigeration system, we wouldn't be cycling as often because the heat gain would not be as bad. Okay, to wrap it up, let's just take a look at what we've discussed and what we've learned here. Okay, so we're using a low pressure switch for temperature control. We have to start off by knowing our pressures. Design temperature difference. Target pressure, which is based on target temperature. Then you got to wire it in properly. Remember, the pressure switch is wired in series with basically the condenser, which is the compressor and outdoor fan. Okay, and then you want the evaporator fans run constantly. Okay, and again, if there is defrost, you don't run fans in defrost. Okay, and then what you do is let box reach design temperature. And dial in pressures. Do not allow short cycling. It will damage compressor. So make sure you set that differential wide enough. And last but not least, subscribe. Okay, hopefully that helped you out with low pressure controls as temperature controls.